All right, today, sum and difference formulas, 7.2. We're going to use sum and difference formulas to find exact values and establish identities. So we need your red sheet again. And the first thing we need to look at are some formulas that look very complex, but they're not. If you have two angles, alpha and beta, then the cosine of the sum of those angles is given by this formula. And the difference of those angles, if you take the cosine of those, is given by this formula. Okay, sum and difference. Here are the sine formulas, and these are all given to you. And there are the tangent formulas. Okay, so now we're going to find an exact value for the cosine of 15 degrees. So we know 0 and we know 30, but we don't know 15. Now I went ahead and took the liberty of calling alpha 45 and beta 30 because 45 minus 30 is 15. Now we don't have to use that. We could use 60 and 45. We could use, what else could give you 15? That's probably about all we'd want to use, actually. So this is really the cosine of 45 minus 30 degrees. So we're going to go to our cosine formula, which is this one, because it's minus. So cosine, cosine plus sine, sine. So we have cosine, cosine, cosine minus sine, sine. I screwed that up. Alpha, beta. Alpha, beta. Alpha, beta. Sorry about that. 45 and 30. So we're going to be able to find the exact value of x at 15 degrees. Now we know at pi over 6, or 30 degrees, it is radical 3 over 2 exactly. So what is this exactly? Well, what's the cosine of 45? Rad 2 over 2. What's the cosine of 30? I just said it. It's radical 3 over 2. Minus the sine of 45 times the sine of 30, which is a half. So the exact answer then is this. Radical 6 minus radical 2 all over 4. That's the exact answer of cosine of 15 degrees. Okay? Now, we can't subtract radical 6 and radical 2. They're not like radicals. So we can't do anything with that. It's done. It's simplified. Now, look at 5 pi over 12 on your unit circle. You will find that it's between pi over 3 and pi over 2. So that's 75 degrees, if you were wondering. So, again, we took the liberty of putting in, or Mrs. Coffee did, pi over 4 and pi over 6 as our angles, okay? Well, this is 45 and this is 30, so that adds up to 75 if we're worried about fractions, but it's really just 3 pi over 12 plus 2 pi over 12, which is 5 pi over 12. So we're going to use the sum now. So pi over 4 plus pi over 6. Well, that is a little bit different formula. That is cosine, cosine minus sine, sine. Uh-oh, I screwed up this formula, didn't I? No, I used minus. We're going to use plus here. Uh-oh, I did mess it up. That should be a plus, shouldn't it? Yes, this should have been an addition. I apologize. So that's going to be plus, rad 6 plus rad 2, all over 4. Yeah, I had the wrong formula going back and forth here. Minus is a plus, right. So this one is going to be a minus, I believe. Cosine, cosine Yeah, plus is minus. So cosine, cosine, minus. So cosine pi over 4, cosine pi over 6, minus sine pi over 4, sine pi over 6. There we go. Okay, so that's radical 2 over 2 times radical 3 over 2. Oh, looks familiar, doesn't it? Minus radical 2 over 2 times 1/2, sine of pi over 6. Well, as you will have guessed, it's radical 6 minus radical 2 all over 4. So these 15-degree increments have a radical 6 and a radical 2, and then all divided by 4 with either a plus or minus. Those are exact answers. And we can't find these without these sum and difference formulas. Okay, find the exact value of sine of negative pi over 12. Okay, well, what if we took pi over 4 minus pi over 3, which is 45 minus 60. That's negative 15, which is what pi over 12 is. A lot of people like putting this in degrees because the math is just simpler. You don't have to worry about fractions. Okay, so this would be sine 45 minus 60. So we're going to go with the sine formula, and it's a minus, so it's this one. So sine cosine minus cosine sine. Okay, so that's our formula. So the sine of pi over 4 is radical 2 over 2. The cosine of pi over 3 is 1/2 minus the cosine of pi over 4. And the sine of pi over 3 is rad 3 over 2. So again, it's rad 2 minus rad 6 all over 4. So that is the exact value of the sine of negative pi over 12. And it makes sense because radical 6 is bigger than radical 2, so it's going to be a negative number, which is what y should be in the fourth quadrant. Okay? Now, I'm going to leave this one up to you. How do you want to find this exact value of the sine of 165? It's totally up to you. You could use 135 and 30. You could use 120 and 45. And that's probably about it, actually. So I'm going to go with 130. No, I'm not. I'm going to use 120 and 45. Okay. Well, this is a plus, much like this. Oh, that was minus. So we have a sine plus. So it's sine cosine plus cosine sine. So sine cosine plus cosine sine. If you've noticed, the angle is always alpha beta. It's going to be in the same order. Now the sine of 120 is 2 pi over 3, so we got to get over there in that second quadrant. Now that's a 60-degree angle or a pi over 3 angle, so it's still rad 3 over 2 because it's positive. Of course, we know that the cosine of 45 is rad 2 over 2. Now the cosine of 120 is negative half because we're in the second quadrant, and that's rad 2 over 2. So the sine of 165 is going to be radical 6 minus radical 2 all over 4, which makes perfect sense. And if you look on your unit circle, you will see those values do make sense when you think of sine in terms of y and how high it is. It should be the same as 15 degrees, or pi over 12. Because this is 11 pi over 12, I think. Yep. And pi over 12 is the same, and they should be. They're the same height. Okay, now tangents are kind of tough because of the fractions, okay? And I'm not sure what Mrs. Coffee wants to do, but as for me, I just have you simplify it into one denominator usually. For the final, I'm not sure. I'll have to see what they suggest if we get one of those on a review. I always like simplifying the whole thing, but because of time constraints on the final, that might be an issue. So pi over 12, remember, is 15 degrees. So I'm going to use 45 minus 30 again. And yes, you can just convert it to degrees if it's easier to subtract. Or this is what, pi over 4 minus pi over 6. Okay, so now we're going to use tangent subtraction, and that's this one. So the tangent of alpha minus the tangent of beta. So the tangent of pi over 4 minus the tangent of pi over 6 over 1 plus, I believe, tangent alpha, tangent beta. Tangent alpha, tangent beta. Now that's multiplication. All right, so here we go. The tangent of pi over 4 is 1. Now the tangent of pi over 6 is this ugly radical 3 over 3, if you recall. And then we're going to take 1 times radical 3 over 3 and get that. Now, technically, this, I think, is okay, but it is not, that is ugly. So if we just use our knowledge of rationals that we done before, but also our knowledge of what we just did with cosines and sines, when we just get a common denominator, and we'd have 3 minus rad 3 over 3 plus rad 3 over 3. And you know what's going to happen. These 3's are going to cancel here. And we get 3 minus rad 3 over 3 plus rad 3. Now, I will let you keep that right there. That is okay right there. To be technical, we would have to multiply by the conjugate and distribute, FOIL all that, to get rid of the radical, which would be 9, let's see, minus 3 rad 3 minus 3 rad 3 plus 3 all over 9 minus 3, which is 12 minus 6 rad 3 over 6, which is 2 minus rad 3. That is the actual answer. I believe on the final we can leave it like this if we get one of these on the final. But this is sure a lot prettier. Is it not? 2 minus radical 3? I think it is. Now on 6, all we do is work backwards. So we find the equation that matches that. What is cosine, cosine minus sine, sine? Cosine, cosine minus sine, sine. That's this one, right? Cosine, cosine minus sine, sine. That's alpha plus beta. So that's going to be the cosine of alpha, and that's beta, plus beta. Well, that's, what do you know? That's 90. So what's a cosine of 90? 0. Done. So that's how you evaluate these. Very simple. What's sine cosine plus cosine sine? Sine cosine plus cosine sine. Sine cosine plus cosine. That's this one. So sine alpha plus beta. Sine alpha plus beta is 20 plus 10, which is the sine of 30. And the sine of 30 is 1/2. And that's it. That's how we do these. So have some fun with formulas. Again, if you know your unit circle, these are not